Hi guys, welcome to this new session on graphs. I have made around 5 or 6 PPTs, which means I'm looking at around 5 or 6 short videos to explain the entire theory of graphs. Well, so let's start by understanding what happened to this topic in the previous few years. Is it important? How important is it if it is important? If it is not important, why are we learning it? So let's take a little bit of analysis on in terms of the exam. Well, that's me. By the way, my name is Srinivas. I'm one of the chief mentors of Career Launcher Bangalore. I've been training students for the last 14 years for various entrance exams. I am an alumnus of IIT Dhanbad, mechanical engineer, and I'm also an alumnus of IIM Indore. I'm a finance major from there. So if you look at what happened in the last 2 years, you will notice that this topic has made an appearance, graph theory, in 2019, but it did not come in 2020. However, if you go back a couple of years, 2017 and 18, there have been questions from graph theory. Also, graph theory or the theory of graphs can be utilized to solve your other questions. So what I mentioned here are purely questions based on graph theory. It is not a mixture of questions, but there have been questions where graphs have been used in other questions also. So it is making sense for us to understand the basics of this. It is not very difficult at all. There are few 7 or 8 rules. That's all you need to understand, and about 6 or 7 basic graphs that you need to understand. So let's take a look at what are these graphs. What do we need to understand about them? So this being the first class, I'm going to introduce to you all the graphs, the basic graphs that you should know. Some of them we already covered in their respective classes. Like in logarithms, we have seen how the log graph looks like. So the same thing I'm going to mention over here. When the base is greater than 1, the graph of a logarithm looks like this. This is base E, this is base 10, this is base 2. So different graphs of logarithms where the base is greater than 1 appear in this way. So the higher the base, the lower the logarithm graph will become. You can see the higher the base, as the base keeps increasing. So if I write base 20, it will start beyond like this, and then it will coming down. So this will become your 20. So the logic is the graph will be steeper, very, very steep before the negative part, or rather before the 0 part, as long as it is in the negative, and it will become very, very gentle. Gentle means very inclined, right? When it crosses your 1. You can see what is happening. Your red is actually the steeper one after 1, but before 1 it is less steeper compared to the other graphs. Whereas green is in between them, and blue is the one which is the highest base. You can see it is the steepest before 1, and it is the gentlest after 1. Now remember the word we use, gentle and steep. Steep means high inclined. This is called steep. Gentle means in this manner. Okay, gentle. Gentle means the angle it is making with x-axis is less. Okay, that's gentle. That's the words they use in graphs. Right, so that's how it looks. When the base is less than 1, or sorry, yeah, is less than 1, that is between 0 and 1, this is how the graph looks like. Okay, so between 0 to 1, if the logarithm graph you have to draw for a base, then you will see that up to 1 it is positive, and after 1 it is negative. It is just the reverse of what we have seen earlier. Here, up to 1 it is negative, after 1 it is positive. Right, so that's how the logarithmic graph looks like. The next graph you're going to look at is modulus. Now, modulus graph is very simple. It is a V-shaped graph. Okay. Now, why is it V-shaped? Because whether you put the positive x in it or negative x in it, the output will be the same. So, if you put x as 2, your answer should be 2. Correct? This is 2. If you put x as minus 2 also, the answer should be the same. So basically your f of x becomes x if x is positive So this becomes y equal to x graph. This is your line y equal to x. But when is this applied? You cannot say this entire line is mine. You will only take the part, this part you will delete actually. And you will only take the part where x is greater than 0. So in this line, you will only take that region where x is greater than 0. Then your f of x becomes minus x if your x is less than 0. So you will say that when it is less than 0, my equation becomes y equal to minus x. So this is your graph. But this graph, this line is actually going on like this. But you will delete this part. Why? Because it is applicable only when x is less than 0. So combining these two, you will get a V-shaped graph. And this is how a modulus graph looks like. If you look at a trigonometric function, some basic trigonometric functions, if you look at sin x, cos x, tan x, I mean, you can pause the video and take a look at this. But at least in this sin, cos and tan, these are the important graphs. These three are important, right? You can see that cos x maximum is +1, minimum is -1. Similarly, sin x maximum is +1, minimum is -1 here. This is a minimum point. And it is cyclical, which means it keeps going up and down like this. It keeps continuing like this. Similarly, tan, it's repetitive in nature. At 0 it is 0, and as you keep reaching pi by 2, that is 90 degrees, you can see that tan x will start becoming closer and closer to infinity. Right, so these are basic graphs. You can take a look at it. You can actually Google it up also, to be very honest. These are available freely anywhere. So observe them a bit carefully. The next graph is a quadratic function. Any quadratic function will be of the form ax squared plus bx plus c. Now, depending upon a, whether a is greater than 0, which is positive, or a is less than 0, so the coefficient of x squared, whether it is positive or negative, depending upon that, you get a graph of this shape. The shape is called as a parabola. The shape is called as a parabola. So the parabola will have a vertex. This is called as a vertex. Here, this is called as a vertex. So the vertex will be the minimum or the maximum depending upon the graph. It will be the minimum point or the maximum point depending upon your a greater than 0 or a less than 0. And the graph continues to infinity here, positive infinity, and the graph continues to negative infinity here. So this is how a quadratic function graph looks like. Moving on, algebraic functions, we look at few functions here. One of the things which you need to understand is x equal to 1 by y or xy equal to 1. This graph is called as a hyperbola. The name is hyperbola. Okay, and the graph looks like this. So this point here, the point where it is turning, this is 1 comma or -1 comma -1, because you can see when x and y are both -1, the answer is 1. And this point where it is turning here, this point is called is basically 1 comma 1. Okay, it will never touch your x-axis or y-axis. Please keep in mind, you cannot, when, so if I ask you when will my x become 0, your x cannot become 0 ever, because if your x is 0, then you're saying 0 equal to 1, because when you say x equal to 0, then 0 into y becomes 1, and that can never happen. So your x will keep becoming smaller and smaller and smaller, and y will keep changing accordingly, but your x can never become 0. This is called as a hyperbola. Okay, there are a lot of theory about it, but we're not getting into all of that because that level of theory is not required for your exam. Okay, so you should know how the graph looks like, and the name of the graph is enough. Then we have y equal to 1 by x square, this graph. Now we have seen y equal to x square, which is basically a quadratic equation, right? Because ax square plus bx plus c, in this, if these two terms are 0, that is b and c, then you'll get y equal to ax square, where a equal to 1 becomes y equal to x square. So we have seen this is a parabola. Now we are looking at y equal to 1 by x square, and this graph looks like this. It is, so basically, if you can notice, it will never touch. Again, remember, this is never going to touch this line. It will never touch your x-axis, it will never touch your y-axis. Okay. In fact, there is a name given to such lines. If you look at this, a line where the graph will never touch, but it keeps going towards that line. It is called as an asymptote. Asymptote is a line which the graph will never touch or cut, but it will keep moving towards it forever. It will never reach it. It will never reach it technically, but it will only keep going slowly and slowly towards it forever. So such a line is called as an asymptote. So here both your x-axis and y-axis are asymptotes. X and y-axis are asymptotes. Similarly, if you look at the previous graph also, here also x and y-axis are called asymptotes. Okay. Now asymptotes do not exist for all the graphs. For some graphs only it exists. Okay. Now the next thing is a general algebraic polynomial, which is an nth degree polynomial, where n is the power of the highest power of your x in that. The graph looks somewhat like this. It's basically a wavy curvy fashion. It can be anything like this, depending upon your coefficients. But it is always going to be a wavy curvy fashion, up and down, up and down. Okay. Now the number of crests and troughs, will always be n minus 1. The number of crests and troughs will always be n minus 1, where n is the highest power of the polynomial. Okay. Next, we will be looking at the entire endeavor for us, looking at, or in the next 4 or 5 classes, is can we find the answer to graphs like this? Can we find an answer to a complex graph like this? And that is what we are going to explore in the next 4 or 5 sessions, guys. This has been the first class, the introduction. You have to realize, or rather remember, the graphs that I just discussed. These are the most commonly asked graphs. We will use these graphs going forward to understand the idea behind transformation of graphs. So we're going to talk about something called as transformation of graphs. Okay. So that's all, friends, for the first video. See you in the second one. Please go through this carefully, understand the graphs, and be ready for the next one. See you.